All right, folks, I wanted to look at some additional ways that you can work with wire and materials to get your sensing apparatuses off of the circuit playground and into an enclosure. The circuit playground is great because it contains so much stuff on it in terms of buttons, a switch, the different centers, the LEDs. But ultimately, if we're making something like a musical instrument or a game controller, we probably aren't going to have direct access to the NeoPixels and buttons on here unless we're very specific in our enclosure design spec. Um, and the shape and form of this works in our favor. So I wanted to go over some things we can do and work with to um, get from here to another surface, especially if we don't necessarily want to solder directly to the circuit playground. Um, so I'm going to go through a whole series of different ways to look at this. Uh, there's not a right or wrong way, but there are some ways that are better um, than others, and ultimately you are trading uh, ease and um, like the ability to move things around quickly with for security and permanence. Okay, so I'm using this little LED as an example. Let's say we wanted to light up this LED. Sticking the LED on here isn't going to work right now. We could jump to a breadboard, but let's say we didn't want to do that right away. Let's say we just wanted this thing in the LED. Let's look at a couple different things we could do. Um, the easiest thing to do will be to use our alligator clips with the female ends, right? So if I clipped this onto our, um, let's see, a 3.3 volt power, and I have another one that I clipped to ground, then I can just stick my LED in here, power for the long side, the short side is ground, and there we go. So that's it. Now I'm going to burn out that LED very quickly, most likely, right? Because I haven't measured anything. I don't know how much voltage it needs. I'm probably overvolting it. So if I did measure it and figure out some of those other things, I could take a resistor and solder that onto the power leg of my LED, and then stick the resistor into that power gator clip and the negative one over there, right, and solder those like that. Um, I can then take this and stick it into a piece of laser cut plywood, um, 3D printed enclosure, right? Anything where I have a hole that's that size, I can push this through the underside and have just the tip of the LED showing, and that'll look like really nice. It could even be cardboard that I'm inserting this into. It's going to look much better than it being like taped to the top. Now, when you're attaching things, um, I recommend using the hot glue. The hot glue acts as an insulator. It's non-conductive, and you can. Uh, it's relatively temporary compared to other glues, right? You can scrape or cut off hot glue with an X-Acto knife if you're careful. Um, so using a little dab of hot glue on the underside to stick this in place will hold it well. Similarly with these connections, right, that's pretty loose. It's in there, but I don't trust that, especially if this is in something that I'm going to be moving around. Similarly with the alligator clips, I'm going to put a dab of hot glue there, a dab of hot glue on this one, between the leg and the connection there. I might even put a dab of hot glue on the alligator clips to hold them in place. That way, while I'm working with this as a controller, as an instrument, as an interface, it's going to stay together. And then when I'm done, if I don't want to keep the project that way, I want to use this for something else, I can scrape off the glue and do so. And again, I'm just talking small amounts of glue. We're not bathing the thing in glue. So that's one way of working with the LED. Now, when I'm making those holes, the best way to figure out the size of your holes is obviously to measure your parts. So I'm going to take whatever my component is and a set of calipers. We have calipers in the makerspace, and measure the width of this part. It is almost exactly 5 millimeters, okay, or almost 0.2 inches. That would be 0.2 inches. You want actually your holes to be just like a hair larger than they need to be, so that you can easily get the pieces in and out. And by a hair, I mean like fractions of a millimeter or fractions of an inch. Like going from here to like maybe there, maybe at most 0.01 inch, just so it has a little loose, it's a little wiggly. When your 3D printing and laser cutting are very precise, but they're not perfect. Sometimes in 3D printing the material like overflows a little bit, sometimes the laser cuts a little too much away. So having just a little bit of wiggle room is sometimes nice, so you don't have to go back and like re-drill all your holes. Okay, that's one way of doing a connection there with those alligator clips. Similarly, if we wanted to use a breadboard with this LED, there's these kind of jumper cables which you may have in your kits. They are male on one end, they are female on the other end. You can get these in any configuration. You can get male to male, you can get female to female, or you can get male to female like I've got here. And you can get like individual ones, right? So you might have one wire. This is 4. You can get them in quite wide thicknesses. They come as a ribbon cable. That'll be a whole rainbow of colors with however many connectors on either end. And you can split off however many you need just by pulling, right? Pulling and ripping it down. There's very thin plastic connecting one color to the next, so you can break that pretty easily. If you only wanted 4, for instance, out of 8. Or if I only wanted 2, if I wanted 2 sets of 2, I could tear this in half. I'm going to leave this one at 4, even though I only need 2. Just like with the alligator clips, I can plug my LED into the female end, and then I can take the male end and plug that into the breadboard, right? If I wanted to directly power it, I could plug it directly into the rails. If I wanted to go to a pin on a microprocessor or put a resistor in there, I could do that and then, you know, jump my resistor in, or I could solder the resistor to the LED up at this end. So if you're working with a breadboard, these are great for doing things like that. Now, even the breadboard, again, for like a controller or an instrument, if I'm moving this around a lot, things from the breadboard can come loose, especially depending on the quality of your breadboard. So I might want to work with my circuit playground off the breadboard, oops, and just take my wire ends and use the screws. And all I have to do, let me see if I've got a wrench real quick. you were an Allen wrench, where would you be? If I've got the right size here. There we go. So again, you want M3 screws for this. You don't need long ones at all if you're just going like through the board to a nut. And like I like the 3D printed spacer to hold the nuts in place. It also helps with tightening because you don't need to put a wrench on the other side because it's being held by all the other ones there. Otherwise you would need a wrench to get it really tight. But these screws are only, let's check again with the calipers. These are like 6mm. Screws. So that's it. You just need 6mm screws. And we'll put that in there. And so then you can just stick your wire underneath the head of the bolt and tighten it down. And now you've got a very strong connection, better than an alligator clip or a breadboard. You can even, if you've got a bare wire, you can bend it into a little hook and hook it all the way around, and that'll be even better. But yeah, if you're working with a Circuit Playground, I highly recommend using the screw terminals for a much more secure bond, and that can help you with debugging too, right? Like you don't have to worry about if you're having like weird behavior that it's a loose wire, right? Because it's secure. Okay. So then, yeah, back to my LED. Let's say I wanted to connect it, or not my LED. Let's say I had something else, like this switch, right? If I wanted to use a nice toggle switch like this, it's got two tabs on here that are either connected or not based on the status of the switch. But if I look at my jumpers, the tabs are too big. They won't fit in there. So I can't use my alligator clips. I can't use my jumper wires. So I need to use my own wires in this case. So when you look at wire, there's a couple different kinds. There's solid core and stranded wire. Solid core is wire like this. When you bend solid core wire, it stays bent. Okay. That's one way of identifying it as solid core. If you look at it very up close, you'll be able to tell that it's solid core too. And I will strip some of this just to show you. So these are wire strippers. They're like pliers, but when you close them, they leave little holes. And the holes have markings on the side here, which tells you the gauge of the wire. So you want to match the hole to the gauge of the wire you're working with. The gauge has to do with the diameter of the wire. And we have these in the makerspace that you can use too. This wire that I have right here is very thin. It's 22 gauge wire. So I'm going to use the smallest 22 gauge setting of these strippers. I grab it about 1/4 of an inch down, hold the wire, and then pull away. And we have a stripped wire. And then we have a little bit of plastic tubing left over there. Okay? So that's how you strip a wire. It's pretty easy. The nice thing about this 22 solid core wire is that you can take a breadboard and you can stick one end directly into the breadboard. Okay? So you don't, since it's solid wire, it's the right size, it goes right in. You can do that with 22 gauge wire and 20 gauge wire. 20 gauge wire is a little bit bigger. The gauges are opposite. your intuition, right? So like a 12 gauge wire is much thicker than a 20 gauge wire. So as the number goes down, the wire gets wider. 24 gauge wire is too thin really to stay securely in the breadboard, and 18 gauge wire is too thick to fit in the breadboard. So really only 22 or 20 will work like this, but that's a nice feature of the solid core wire. The downside to solid core wire is if you bend it back and forth repeatedly, just like a coat hanger, it will snap eventually. So if I was working with this part, I would cut 2 pieces of wire. I would solder one end to each of my terminals, and then the other end I could stick into the breadboard like I just showed you. I could screw it to one of these screw terminals, etc. Right? So if I wanted to have this button, like up here in space from my controller, I could do that with 2 little pieces of wire and just soldering to this button. And while that soldering is mostly permanent, right? Like there are ways to undo soldering, but it's usually not worth it. Adding wires to a button is rarely going to prohibit you from using the button in the future, or switch or something like this. Now, similarly to the LED, if I was going to put this in a panel, I would want to measure the hole. This has a much wider post, so I'm going to measure that, and we've got this one is 15, 16, 17, 17.6 millimeters, or it's just a smidge less than 0.7 inches. So I might make a 0.7 inch hole again, so I have that little wiggle. The beautiful thing about a lot of switches, buttons, knobs, potentiometers, things like that, is that they'll come in a form called panel mount, which means they're made to go onto a panel, and sometimes that means they will snap into place, or like this switch, they will have the post will be threaded and they'll have a nut. So if I made that 0.7 inch hole in my 3D printed top, in my cardboard, in my laser cut acrylic, whatever, as long as that thickness is the thickness of the material is thinner than the threads, the length of threads I have, right, which looks to be about 1/2 inch. So as long as I've got thinner than 1/2 inch material, I can stick this through, and then from the underside put this back on and tighten it down, and that will hold this button really securely in place and in the orientation that I want it, right? If I want it that way or this way. So you can look for connectors like that. And I've got like another, this is an audio jack that I've soldered wires to, right? Its terminals, so that I could plug it into a breadboard or, connect it to screw terminals. And it too has a little nut and washer where I could slip this into a panel so that only the connector is exposed. Last one, another one of these. Big button, toggle button, same thing. Nut, threaded post, measure the diameter, put it through your material, and then tighten up the nut. Yeah. All right. So that's solid wire. The other kind of wire is stranded wire, which your alligator clips are probably stranded wire. Your jumper cables are probably stranded wire. You could tell stranded wire if you bend a wire and it just kind of like wiggles around. It doesn't stay in place. It feels very loose and floppy. It's probably stranded. So things that get moved around a lot, like alligator clips, because they're reusable, repurposable, are going to often be made with stranded wire, right? So like if you have wire going across a hinge in a door or something that's going to get bent back and forth a lot, you definitely want to use stranded wire. It is a wire that's basically braided or twisted from many very thin wires, which gives it some flex, right? So it too eventually will break if it's wiggled back and forth over and over, but it will take much longer than solid core wire. So looking at that, here is some, I think this is stranded wire. Let's see. So, and the wire might be silver colored on the inside or copper colored. That doesn't particularly matter. But you can see as I poke the end of this, the strands, right? I'm separating out the strands and it's fraying. So this wire is very poor to stick in the breadboard, right? Because it's going to spread out and make a mess and short out other things and connect to other stuff. It probably won't even stick in there and hold. So I can't use the stranded wire for the breadboard. I can twist it back together if it does get frayed, right? But even then, like twisting, it makes me, I don't like it. It makes me nervous. You can tin the ends. We call it tinning the ends, which is where you put a dab of solder on the end of a stranded wire, and that holds it all together. So these ends have been tinned, and they are, you can see I'm poking it, and it's pushing into my finger. It's not gonna fray. And those, again, like maybe you could stick those in a breadboard once they've been tinned. You want to be careful with the stranded wire too. You can twist it and make that hook shape for a screw post if you want to, but you do want to be very careful that it's not fraying at all when you put it in the screw terminal, because you don't want one little piece to like unfurl and hit the post next to it, right? Because again, that will create a short or a jump that you don't intend. Okay, so those are our two different types of wire. A couple other things for you. If you have something with a lot of wires, I've got an example here of an infrared sensor. It has a very long cable in it, but this is a sensor. It's got 4 wires. They're not together nicely, which is unfortunate. They're not ribbon wire. But I wanted to plug this into a breadboard. So what I did, they were stranded wires, is I just took some header pins, 4 header pins, and soldered those to the ends of these wires so that I could take that whole thing and plug it into a breadboard and work with the wires that way. Okay, that's a really great thing to do. Now, I made a mistake here though, or I neglected to do something. If I am going to do this and put header pins on there, these connections are not the strongest, right? And there's going to be a lot of force and wiggle on there. So I want to reinforce those if I can. And the best way to do that is to just take a piece of regular Scotch tape, put it on the back on one side, and then use a blob of hot glue on this side, and then fold the tape over and squish it without burning yourself. So maybe wear gloves or use pliers to do the squishing. That creates like strain relief for this. And again, the tape and the hot glue are not conductive. So as an example of that, in 2 places on this force-sensitive resistor, first I soldered 2 little wires to the legs, and you can barely see them through the tape there. But there's a little piece of tape and the glue just so it doesn't bend or disconnect or break where that fragile connection is. And then same thing, I wanted header pins, so on the other end of this component I put header pins so I could stick it in a board, and I glued in tape where I soldered those. So it's a really good skill to have and practice to get into when you've got your sensors. A lot of times when you get sensors, they're going to come with just bare wires on the other end, like this capacitive microphone, piezo microphone. It just has 2 wires, right? Knowing, being able to solder some header pins on there if I want to go into the breadboard, or strip these a little bit longer if I wanted to go to screw terminals. Being confident and comfortable doing that is really important to your future work in electronics, right? Because ultimately you're going to want to get off of having to rely on everything being stuck to the board itself. Which reminds me, the last thing I'll mention, in thinking about ways to attach stuff, right? These cases for the Bluefruits actually show you a couple strategies on the back, and this could be incorporated into almost any kind of case that you're laser cutting or 3D printing. It's got these 2 slots, right? And I think they're a little bit bigger than an inch long, but that's for a piece of webbing material. It's like if you had a strap, not as wide as a seatbelt strap, but some nylon webbing that you can get at like a craft store. You could thread that through there. That's great if you want to make like a bracelet or a glove or some kind of wearable, because you could sew that strap into a garment, or attach it with D-rings, or it could be a Velcro strap and then it just gets stuck onto the other side of Velcro that's on a glove or a wristband or something like that. So just having a couple slots like that and enough space for the material to fit is a great way to strap it onto something. The other thing that's on here is a little threaded insert. You can get threaded inserts at the hardware store. And this is a 1/4 one. 1/4 means the diameter is 1/4 inch and 20 is the threads per inch, so 20 threads per inch. That's a nice size. The accompanying bolt would be a 1/4 bolt, but 1/4 is also the size that's used on almost all tripod camera equipment, right? So if you've got a nice camera, it probably has a 1/4 threaded insert on the bottom of it somewhere. If you've got a tripod and you look at the top of it, it probably has a 1/4 bolt, just a very short one, but sticking out the top, and you screw this in there. So if you're looking for a way to like screw this down, within an enclosure, using a 1/4 nut will work for that. Or if you're making some other kind of 3D printed enclosure you want to put everything in, you can get your own threaded insert and just push fit those into the appropriately sized hole. You have to measure, because the threaded insert is going to be bigger than a 1/4 inch. Make your hole the right size, but those are just press fit. So yeah, that's looking at a couple different ways to get your sensors, buttons, switches, and knobs off of the Circuit Playground and onto something more durable.